Day students. This is some notes on the standard deviation from the mean. And we normally have, if we collect data, and it's in sufficient quantities, the data behaves like a bell curve, which is also called a normal distribution. You can see in the middle, that's where the mean is, and we know how to calculate the mean. We will revise that a bit later. Then you can add one standard deviation, you can subtract one standard deviation. It will include 68% of the data. If you add two standard deviation to the mean or subtract two standard deviation, it will actually cover 95% of the data. If you add three standard deviations either side, and subtract it from the mean, then you will get 99.7% of the data. So the greater the amount of data that we have, the greater the accuracy, and the closer it will be to a standard distribution, a normal distribution. Now, the mean is quite unreliable because that if you use it on its own, because it can be distorted with very large or very small data. And so it's very important to use the mean together with the standard deviation. Now, the relatively greater the standard deviation, the less the reliability of the data is. The smaller the standard deviation is, the more reliable it is. And we'll go into that a little bit, but that's not the main aim of this presentation. We show three examples below. In the first, we actually show how the standard deviation from the mean is calculated. And then we show how to use the calculator as a shortcut. And in the last two examples, we only use the shortcut because the shortcut is what you're required to use in the exam. So let's start with our first example. An experiment was conducted, and the following results were given. 2, 4, 6, 7, 9, 12, 13, 15, and 17. So let's list the data in the table. And if you add all the data together, you'll get 85. Now, to calculate the mean, as you know, once you add up all the data, you divide it by the number of data. In this case, we've got 9 sets of data. So 85 divided by 9 is 9.44, and that is the calculation for the mean. Now, next we calculate the distance of each data from the mean. And so we say 2, our first data, minus the mean, which is 9.44, and we get minus 7.44. And we do the same with each of them. And you can see there, 4 minus 9.44, 6 minus 9.44, and so on, right up to the end. What we do then, we add it all up. This is now the data minus the standard deviation, minus the mean. The problem is, you can see some of the data has got minuses, other data has got pluses. So the problem is with this is that the minus cancels with the pluses. And so if you add it all up, we only get 0.08. And so that's not a reliable indicator of the data. So what we use then is we use the square of the distance between the data and the mean. And we square each of that. So a square of minus 7.44, and you get 55.3536. Square of minus 5.44, you get 29.5936, and so on. Now we add up all of those squares, and we get 210.224. And now the next step is that we divide what the sum that we've got, the adding of all the squares between the data and the mean, add it all up, and we divide it by the total number of data, which is n. So 210.224 divided by 9 gives us the standard deviation squared, which is otherwise called as the variance. We won't go into that now, but later in another episode. So the standard deviation, therefore, has to be the square of the sum of x minus the mean all squared divided by the number of data. And if you do that, you get an answer of 4,833. So now let's look at our performance on the calculator, and let's enter the particular the data. So let's put on the calculator and let's put on mode. So now we're going to go to 3 for statistics, and now we're going to go to 1 for one variable. And so now we start to enter our data. Here's our data. So it's 2 equal to 4 equal to 6 equal to 7 equal to 9 equal to 12 equal to 13 equal to 15 equal to, lastly 17 equal to, and then we press our AC button, and then we're ready to press shift, and we go down to our statistical button. Then we're looking at 4 for variance, and now the 2 there is going to give us the mean. So let's just double check that. We press the 2, and there's the mean coming up, equal to 9,44, which was exactly what we calculated. So let's go back to AC, and now let's press the shift and go back to statistical, and let's go back to number 4 for variance, equal to, and now number 3 there, that is where the standard deviation from the mean is. So let's press a 3 and equal to, and there we get 4,833, which is exactly the same as what we did when we did our particular calculation. So that shows you that this particular, the sum of the squares of the distance between the points and the mean, all squared, that sum, if you get it and you divide it by the number of data and you find the square root of it, that is your standard deviation from the mean. So now it's for us to say, well, x plus 1 standard deviation, that's so the mean plus 1 standard deviation gives us 14,273. The mean subtract 1 standard deviation, that's 9,44 minus 483, we get 4,61. And so now we go back to our data. Let's take the 4,61, and if you look at the data, it's only 4 and 2. That's 2 that is less than it. And let's take the one that's 14,273. So 15 and 17 are the only 2 that is out, that's above it. And therefore 2 below and 2 above are outside 1 standard deviation. Therefore 4 bits of data is outside of 1 standard deviation. Therefore 5 over 9, that is 56% of the data, is within 1 standard deviation. That is 40% is outside. It differs a little bit from the normal distribution.